Hey, welcome everybody. This video is going to go over the 10.6 notes for Algebra 2. This is Mr. Gannon, and as you go through, make sure you guys are filling out the notes. But before each example, I'd recommend that you pause the video and try the problem on your own first to see what you come up with. You might not be able to do that for the first part, but from then on, you should be able to. So we're going to be looking at properties or solving exponential equations. And in order to do that, we're going to use a property of equality for exponential equations. And this is essentially what it says. If b to the power m is equal to b to the power n, then in order for that to be true, m has to equal n. So if we have two exponential terms that have the same base, which in this case they're both base b, then the only way that those two equations are going to be equal to each other is if the exponents are equal to each other. And for now, that's the only property we're going to have that we can apply to these exponential equations. So that's what you want to be thinking about as you go through and solve these problems. So if we take a look at this example here where it's saying work with a partner. Okay, obviously we can't do that at the moment, but what you want to recognize is you've got 2 and 2 as the base of the exponential. A lot of times what I've heard people say in this case, once the bases are the same, is you just drop the base. You get rid of the base. Now we have x plus 4 equals 2x plus 3, and that's a pretty basic equation to solve. So we want to move the variables to one side. I like to keep the x's positive, so I'm going to subtract x on both sides, which is going to give me 4 equals x plus 3, because 2x minus x is x. And then we're going to go ahead and subtract 3 on both sides, x equals 1. And that right there is how you can solve an exponential equation if they have the same base. Now, you will notice throughout the notes that you're going to run into some problems where the bases are not the same. So your job initially is going to be to find a way to rewrite them using the same base. All right, if we keep moving, let's go ahead and take a look at number 1. Again, I really recommend you guys pause the video, try the problem on your own, and then see how we do it. So for number 1, it says 2x to the first power equals 32. So on the left side, we have an exponential term in base 2. On the right side, we have 32. Really not written as an exponential. But if we're going to be able to apply these properties, we need both sides to have base 2. So we want to figure out, okay, can 32 be written as 2 to a power? The answer to that is yes. 32 is 2 to the 5th power. Because 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So if you multiply 5 2's, you will get 32. Once you have the same base, drop the base, set the exponents equal, x minus 1 equals 5, and then we can solve, add 1 to both sides, x equals 6. That's all there is to it. It does say check your solutions. Well, if you plug in 6, 6 minus 1 is 5. And if you plug 2 to the 5th power in a calculator or multiply 2 5 times, you will get 32. All right, let's move to example 2. Again, pause the video, give it a shot on your own. But what I recognize first is you have two exponential terms. They are both base e. So all we're going to do is drop the base. From there, 3x equals x plus 12. We need the variables to be on one side, so I'm going to subtract x. 2x is equal to 12. And then we can divide both sides by 2. And our final answer, x equals 6. Again, you can do a quick check. 3 times 6 is 18. 6 plus 12 is 18. So that's basically saying that e to the 18th power is equal to e to the 18th power. which is absolutely true. All right, number 3, a little more challenging of a problem, but it's the same idea. On the right-hand side, you have this exponential term in base 4. So with the tools that we currently have, we are only going to be able to solve this if we can write both sides in the same base. So pause the video, see if you can figure out how to write 1 over 64 in base 4. All right, guys, hopefully you were able to come up with it, but in this case, if we want these both to be in base 4, right, we already have the right-hand side as 4 to the 2x to minus 4 power. So we need to think about, all right, what power of 4 is going to give us negative 64? Well, hopefully you're thinking that 4 cubed is 64. So that'll give us 64, but how do we make it 1 over 64? And the answer is you make the exponent negative. So we want this to become 4 to the negative 3rd power. All right, now we have both sides in base 4. Drop the base, set negative 3 equal to 2x minus 4, and solve the equation. Add 4 to both sides, 1 is equal to 2x, and then we can divide both sides by 2. X is 1/2. Okay. So, something else you got to think about, but with that 64 on the bottom, 4 to the negative 3rd power becomes 1 over 4 to the 3rd power, which is 1 over 64. Now, another issue you could run into is a problem like number 4, where you do have exponentials on both sides. They do not have the same base. And it's not possible to write 27 in base 9, right? 27 is not 9 to a power. So think about what you could do in this situation. All right. Well, the answer is to find a base that they can both be written in. So we're going to go ahead and we're going to rewrite the left side and the right side, those bases, using a different base, all right, that they have in common. Well, I know that 9 is 3 squared, and I know that 27 is 3 cubed. So basically, we changed both bases to 3, and now we can apply properties of exponents. So we're going to multiply the exponents. This becomes 3 to the 4x. And then over here, we got to multiply, which means distribute. So this is 3 to the 3x plus 3. Exponentials have the same base. Drop the base. Set the exponents equal. And solve. So in this case, if you subtract 3x on both sides, you get x equals 3. And for us, at this point, that is all there is going to be to solving those exponential equations. You want to make sure that you can write both sides in the same base. And then at that point, you drop the base to set the exponents equal and solve the resulting equation. All right, there are 3 examples below. Go ahead and try all 3 on your own. See what you come up with now that you've seen a few examples. All right, see if you've got a better grasp of this. I am going to complete these for you. All right, so watch the rest of the video and compare how you did. So if we take a look at number 5, same base, drop the base. We're going to set 2x minus 9 equal to 5x plus 6. So now we just have to solve for x. I'm going to subtract 2x from both sides. So 3x plus 6. Now I'm going to subtract 6 from both sides. So that'll leave me with 3x on the right side. And then if I take away 6 from negative 9, that's negative 15. And then finally, we're going to divide by 3. X equals negative 5. All right. That's 5. Now compare what you got on 6. So for number 6, the left side has an exponential in base 2. The right side is just 1 over 32. So I'm going to start by rewriting both sides in base 2. Now, because it's 1 over 32, I need a negative exponent. And the power of 2 that's equal to 32 is 5. Same base, we're going to drop the base, set the exponents equal. 3x plus 1 equals negative 5. If we solve that, we're going to go ahead and subtract 1. So 3x equals negative 6. Divide by 3. X equals negative 2. And we're done. All right, and then if you go ahead and you take a look at number 7, all right, we've got exponentials on both sides, but they do not have the same base. All right, and I cannot write 64 as a power of 16. So we've got to start by changing the base on both sides. So the question is, what base will 16 and 64 have in common? The answer is 4. 16 is 4 squared. 64 is 4 cubed. All right, so from there we apply properties of exponents. We now have 4 to the 6x equals 4 to the 3x plus 6. Again, you're going to multiply these exponents, so you have to distribute. Once they have the same base, drop the base. 6x equals 3x plus 6. We're going to subtract 3x from both sides, so 3x is equal to 6. And then if we divide both sides by 3, x equals 2. All right. Hopefully those went well for you. If not, guys, you're going to have more practice on the homework assignment, but this essentially is what's new in 10.6. Now, if you do go to the next page in the notes, just so you guys understand, we're going to skip these problems. So go ahead, guys, put a big X through that page of the notes, cross it out just so you know you didn't miss anything. So the only thing new in 10.6 is solving exponential equations by rewriting them in the same base. All right, guys, hope this helps you with the homework. I will see you next class.